Hello and welcome to our lesson on the cosine curve, which is the name of the graph that is produced by y equals the cosine of theta. So this would be a piggyback off of the lesson that we talked about with y equals the sine of theta, or the sine curve. Just like with the sine curve, when we're graphing the cosine curve, we're reading it the same way we're reading the unit circle. Okay, so we're going to make a table. We're going to graph this on the interval from 0 to 2 pi. Just like we did with the cosine curve, and what we're going to see is one cycle. So when we look for the cosine of 0 degrees or 0 radians, remember cosines, those are the x values in our coordinates. So at 0 degrees or 0 radians, our cosine is going to be 1. And then we're going to ignore all these fractions. We're going to skip around to the cosine of pi over 2 or 90 degrees, which is 0. And then again, we're going to skip all these fractions here, here, and we're going to go to pi radians, or 180 degrees, where our cosine is -1. And then we're going to skip to 3 pi over 2 radians, where our cosine is going to be 0. And then we're going to get full circle here, back to 2 pi, which is the same as 0, and our cosine's back to 1. And then we're going to see those same numbers repeat if we were to continue around the circle. So at 0, at a 0 degree angle or a 0 radian angle, our cosine is 1. At pi over 2 radians, our cosine is 0. At pi radians, our cosine is -1. At 3 pi over 2, we're at 0. And then at 2 pi, we're back up to 1. Okay, so this is what one cycle of our cosine curve will look like. Let's see if I can draw this nicely. And something like that. It's not terrible, okay, where we have a midline still at 0. And we can see our amplitude of 1, where we're going up 1 from the midline, down 1 from the midline. So this is, again, a one cycle of the sine curve. Okay, and this is again a periodic function, just like our sine curve, with an amplitude of 1 and a period of 2 pi. Remember, the period is how long it takes for one cycle to happen. And on the interval that's shown, we are, let's see here, we are increasing on this interval, right, where the cosine value is increasing. Well, that's going to be from pi to 2 pi. So from pi to 2 pi, and really we could write that as an interval. And then decreasing, use another color here, we're decreasing for the first part of the graph. Our cosine values are getting smaller, and that's from 0 to pi. So from 0 to pi radians. And positive, we have two separate intervals. Remember, positive means we're above the x-axis. So this portion is positive, and this portion is positive. That's where our cosines are positive. Positive x's, those happen in quadrant 1 and quadrant 4. So that's the first quarter of the graph and the last quarter of the graph. So we're positive from 0 to pi over 2. And again from 3 pi over 2 to 2 pi. Negative, where the cosine's negative, that's where the x values are negative. That's in quadrants 2 and 3. So that's the middle two quarters of the graph. So we're going to say we're negative on this interval here, which is the one interval from pi over 2 to 3 pi over 2. Okay? And we reach a maximum value. So this is a max at 1. Same max over here at 1. And this is our minimum at -1. Again, it's y equals 1, y equals -1. So we reach a maximum value of 1. And that happens technically at the beginning and end of the cycle. So at 0 and at 2 pi. And then we reach the minimum value of -1, and that happens just once at pi. Okay? So really, the comparison between the two, if we're looking at sine and cosine now that we've seen them both, lots of things in common. And if you could just look at the two pictures, where the sine curve was the one, remember, that starts at 0, that's the red one here, the one that I'm now highlighting yellow, Okay, the cosine curve. The cosine curve, that's the one that we just looked at here. If you can see it, one is just a translation of the other. If I took that blue one or the yellow one and I shifted it, if I shifted just pi over 2 units, you would see that those two graphs would match up. In fact, let me see if I can do something here so I can show you. We'll see how techie I can get here. Let's see. Cut. And then if I paste it. Yep, look at that. Okay, so here's our sine curve. Oh, it's so techie. Here's our sine curve. If I take it and just shift it pi over 2 units, it lands right on top of the cosine curve. Or if I take the cosine curve and shift it pi over 2 radians to the right, it lands right on the sine curve. Okay, so one is just a translation of the other. They have the same maximum and minimum values, right? Both reach a maximum of 1, both reach a minimum of -1. They have the same amplitude of 1, right? 1 unit above the midline, 1 unit below. They have the same period of 2 pi. It takes both of them 2 pi radians, a full circle, to complete the pattern, to complete one cycle. Same pattern of repeating y values, where we have a y value of 0, 1, 0. Let me show you where I'm going. 1, 0, -1, 0, 1. And again, that happens here. 0, 1, 0, -1, 0. It's just they're offset a little bit, but they are the same pattern of repeating, right? So they both have the 1, and then they have the 0, and then they have the -1, and then they have the 0 again. Okay, so the same pattern. The only difference is where they start. The difference is the starting point. Sine, if you can, oh my gosh, I dropped my pencil. The sine, if you can remember, always starts at 0, and the cosine starts at its max, which in this case is 1. Now that's for the parent. Obviously we know that we can shift, or we can stretch this out by changing the amplitude, but the parent starts at its max, which is 1. Okay, so now we have some, transformation rules that we looked at last time with the sine curve. I graphed them for you here so you can see it. So this is our basic cosine curve. If we change the 1 in front to a 3 in front, just like with the sine curve, what that does is it vertically stretches the graph. So the vertical stretch in this graph we see increase the amplitude. So that makes our amplitude 3. If we put a 3 in here, that's a horizontal compression of the graph. And what we see happen with the horizontal compression is, well, we've got one cycle here, and then we have a second cycle here, and then we have a third cycle here. So this horizontal compression changes the number of cycles from 0 to 2 pi. So 3 cycles from 0 to 2 pi. Okay, and then we also know the negative. The negative is reflecting the graph over the x-axis. And so instead of our graph starting at its max of 1, if we reflect over the x-axis, it starts at its min. So this reflection over the x-axis, the effect is starts at the minimum instead of the maximum. Okay, so same things really that happened yesterday. We looked at the parent, y equals cosine theta. Now if we change the coefficient here and the coefficient here to numbers other than 1, then we're going to change how many cycles we have from 0 to 2 pi, and we're going to change the amplitude. Now specifically, A in the cosine curve shows us where the cosine curve is going to start. If our cosine curve has an amplitude of 1, if there's a 1 out here, then we're going to start at +1. If our cosine curve has an amplitude at 3, if there's a 3 out here, then we're going to start at 3. And if our cosine curve has a -1 in front, our amplitude is 1, but that -1 tells me start at -1. And so the number that's in for the first coefficient, a, not only affects the amplitude, but it shows us the actual starting point for the cosine curve. So a is the starting point. And again, the absolute value of a is going to give us our amplitude. And then b shows us the number of cycles from 0 to 2 pi. And the period is the horizontal length of one cycle, so how long it takes for one cycle to happen. And remember, we can calculate that period by taking the standard 2 pi interval and dividing it by how many cycles have to happen in that interval, so 2 pi divided by b. Okay, so let's look at a couple of more functions here, make sure we've got a good grasp on what's happening. So we're going to identify the amplitude, the period, where this graph starts. Basically, what can we tell by looking at this function, what's going to be going on with the graph? So based on a being 4, we can see that this is going to start at 4, and there's going to be an amplitude of 4. And we can see that b, I should have just put this here. I wrote the same thing twice. It's not helpful. So amplitude is 4. And then because b is 1/6, there's going to be 1/6 of a cycle from 0 to 2 pi. So then how long would it take for a full cycle to happen? So remember, the period says take 2 pi and divide it by b. Well, dividing by 1/6 is just multiplying by 6. So that means it would take 12 pi radians for a full cycle to happen, which would make sense, right? 1/6 of a cycle in 2 pi. So you would need 6 of those in order to complete the cycle. So the period is going to be 2 pi here. Okay, so all the information's pertaining to that problem. And then over here, I can see, because a is -5, that this graph is going to start at its minimum of -5. So it starts at -5, and the amplitude is going to be 5. And because b is 8, that means this graph would have 8 cycles squeezed in there from 0 to 2 pi. So 8 cycles from 0 to 2 pi. And then the period is how long would it take for one of the cycles to happen? Well, if we have 2 pi being divided up amongst 8 cycles squeezed in there, then it's only going to take pi over 4 radians, or 1/4 pi radians, for one cycle. And I should have written that over here too. 12 pi radians for one cycle. And just want to make sure. Okay, all right, so now let's see. We should also be able to look at the curve and, based on what it's showing us, decide what the function should be here. So we can identify a and b, then we're good. A, the starting point here, is a -1, so there's got to be a -1 in front of this cosine, and I know it's cosine, not sine, because it's starting at the max, or it's starting at the min and not starting at 0. And the cosine curve, right, should start and stop at the same level there. So if we're starting at the max, we should end at the max, and we got to hit the min in the middle of that. So what I'm seeing here on this one is we're starting at the min, and then we've got the middle max, but we're not getting back down. So this is only half of a cycle. That means b has to be 1/2. So then this is going to be y equals -1 in front of the cosine of 1/2 theta. And if you weren't sure, you put that in Desmos and you confirm. Okay, now let's try to sketch the graph for y equals 2 times the cosine of 4 theta. So I need to start at 2. So this is going to be 2, -2. So we're going to start this graph at 2. And we have to fit 4 cycles. So 4 cycles. And this is the start. Okay, so if I have to fit 4 cycles in here, I'm trying to graph this by hand, what I really need to know is how quickly do I have to finish one of those cycles. So I'm going to go ahead and calculate the period. So the period is 2 pi divided by 4, which means I have pi over 2 radians to finish one cycle. So I have to finish one in this block, and then I have to finish a second one, and then a third one, and then a fourth one. So I got to fit 4 cycles in there. That means each one is going to have to be completed in that pi over 2 radians. So let's do this. We know that the cosine curve, and this one's sorry, it's not reflected. It's starting at 2, and it's got to end at 2. So I'm going to start and end in that pi over 2 radians, and in the middle of that, it's got to hit its minimum, and then in between the maxes and mins is where we hit 0. So there's one. Right, and the second one's going to do the same thing. It's going to end here at pi. It's going to hit the minimum in the middle, and then between those it's going to 0 out. And then again, here, 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 and then one more time we're going to end there, hit there, hit there, hit there. So it's 1, 0, negative 1, 0, 1. Over and over and over again. Now I just need to try to connect the dots and make this look kind of fluid. Easier said than done. Although this isn't looking too bad, I'm gonna say I'm a little proud of myself here. And boom, there we have it. Okay, amplitude of 2 and 4 cycles squeezed in there from 0 to 2 pi. Now, when you do this in Canvas, you're going to probably be required to upload some pictures from Desmos. So let's just go ahead and make sure we know how to do this in Desmos. And just delete all that out. So we want to confirm that our graph is right. We're going to put in y equals the, go into functions and trig, find the cosine of x or theta. It's going to be the same thing. Oops, forgot. We want an amplitude of 2, and we want 4 cycles in there. Now I just want to look at the window that's on my paper here. So let's make the x-axis go from 0 to 2 pi, and with a step of pi over 2. So pi over 2. And then the y-axis, I'm going to have it go from negative 3 to 3 just so I can see clearly. And that should do it. And there it is. Looks pretty much like what I've got there on the paper. They look a little spikier than mine, but that's just because I had it go out of... Oh, I done messed it up. Let me see. Can I undo? Undo. Nope, just kidding. Okay. So there it is, exactly what I put on the paper. So you can confirm, and that would be the picture I'd be looking for here to make sure it's captured the correct window and all the settings. Okay? So not so bad now that we've already established what's going on with our sine curves. This is just piggybacking. It's really the same thing. We just start shifted over a little bit. And we call that shift a phase shift. It's a translation, so in any other function when we translate to the left or to the right, we call it a translation left or right. For some reason, we like to get fancy with our trig functions and call the translation left or right a phase shift. So we have a phase shift of pi over 2 radians. We shift by 90 degrees, but it's just a translation, okay? So if you run into some of that terminology, a phase shift is just a translation. In any case, I think you have enough information to get going on your practice, but as always, if you need some extra help, then just reach out. All right, guys, take care.